Now after innate immunity, now let's talk about adaptive immunity. Now to understand adaptive immunity, first thing you should understand is, this is the favorite story which I always tell everybody. This is a typical Bahubali story which I always tell my students. Okay, so now you all know, everybody knows Bahubali, isn't it? So in Bahubali there was a king. Okay, and king has its own, don't say queen, army. Okay, has its own army. Okay, so it has its own army. So king was the T cell. King was the T cell, and the army was called antigen presenting cell. The army was called antigen presenting cells. Okay, so now these antigen presenting cells were of three types. Okay, B lymphocytes. Okay, dendritic cells. B lymphocytes, dendritic cells, and macrophages. So D is for dendritic cells. So we have T cells and the antigen presenting cells. So what were the three antigen presenting cells? B lymphocytes, dendritic cells, and macrophages. Okay, so out of these three, who was the most powerful, okay, antigen presenting cell? So in the Bahubali stories, and who was Kathappa of the story? Okay, so who was Kathappa of the story here? This is dendritic cells. So most powerful antigen presenting cell is dendritic cells. So what is the function of antigen presenting cells? Antigen presenting cells should catch the antigen and it should go and present it to the T cell, and then T cell will decide what has to be done with that antigen. Okay, so T cell is the king. Okay, so therefore this dendritic cell will catch the antigen and give it to the T cell. Now once you know that, see here again you should know that when I talk about dendritic cells, okay, so in our story we have twin Kathappas. So we have twin Kathappas. Okay, so we have follicular dendritic cells and interdigitating dendritic cells. So what are the two types of dendritic cells we have? So we are having follicular dendritic cells. So we are having follicular dendritic cells, and we are having interdigitating dendritic cells. Okay, these are the two types of dendritic cells. Now again I am asking you, which is the most powerful antigen presenting cell? Now you have two Kathappas. Who is the most powerful Kathappa now? So the most powerful antigen presenting cell is IDC. Okay, interdigitating dendritic cell. Why? Because of its location. IDCs are present all below the epithelial surfaces of the body. Now because they are present all below the epithelial surfaces, they are at the perfect site to catch the antigen and to give it to the T cells. So they are at the perfect site. That is why they are the most powerful antigen presenting cells. Now follicular dendritic cells are also very good antigen presenting cells, but they have another function. What is the function of this? So remember, follicular dendritic cell, what is the function of follicular dendritic cells? So let's see. So if you look at the lymph node of your body, okay, so in the lymph node we have the follicles. So these are the follicles of the lymph node. Okay, so follicles are present in the cortex, and cortex is usually in the follicles usually we have, who stays there? B cells. So normally whenever, this is the bone marrow, okay, and from the bone marrow naive B cells are released. From the bone marrow naive B cells are released. What are these naive B cells? These naive B cells are like +2 students who don't know anything, okay, and they are entering into the medical college. Okay, so these are naive B cells, they don't know anything about immunity, nothing. So now they come into the follicles of the lymph node. So they have entered into the medical college. So in the medical college, who is waiting for them? Who is waiting for them? Their teachers, isn't it? Their teachers are waiting. So who is the teacher of B cell? Follicular dendritic cells. So follicular dendritic cells are present in the germinal center of the lymph node. Okay, so now what happens? Now as soon as these follicular dendritic cells are, they are waiting. So as soon as the naive B lymphocyte enter into the follicles, follicular dendritic cell is a very strict teacher. So it says, see, this is a medical college, okay, like the Kabir Singh says, no, see, this is medical college, Preeti, you have to know how to study. So this is a medical college, so you have to be very serious, okay, so you have to be very serious, okay. So what happens? So they form a rule, they say, no, we will form a dedicated area here, okay, so we will form a dedicated area where we will do the training. So you have to study well, you have to learn well, okay, and so they will form a dedicated area here. So they take, so these follicular dendritic cells, okay, form a dedicated area inside the follicle of the lymph node. This dedicated area was called as germinal center. What was this called? Germinal center. And in the germinal center, this teacher is there, and all the naive B lymphocyte now enter into this. So they said they are very strict. So they said there is a rule in the germinal center. What is the rule? The rule of the germinal center of this classroom was that there will be no BCL2. So this part of the lymph node will have no BCL2. Do you understand the meaning of this? Do you understand the meaning of this? This has no BCL2. What does it mean? It means because there is no BCL2, anybody can die. So this is BCL2 is an anti-apoptotic molecule. So if there is no anti-apoptotic molecule, that means apoptosis can occur at a very fast rate. So germinal center of the body is one part where apoptosis occurs at a very fast rate. So here apoptosis is occurring at a very fast rate. Okay. Now, so when apoptosis can occur at very fast rate, now B lymphocytes are there. So what our FDC is going to do? So all B lymphocytes are thinking, what is our teacher going to do with us? So now follicular dendritic cells are very good antigen presenting cells. So they will catch the antigen and they will start giving it to the B lymphocyte. Obviously, in the first go, B lymphocyte will not know how to form the antigen. So they do not know how to form the receptors, isn't it? So they don't know how to react to the receptors. So what happens? So now they don't react to they do not know how to do. So obviously they will not be able to react to the antigen well. So FDCs will teach them, okay, how to react to the receptor. So they tell him, no, this is not the way to catch the antigen. Change your antigen. Change your receptor according to the antigen. So these receptors will go lot of somatic hypermutation. So these receptors will go very fast somatic hypermutation. That means mutation is occurring, okay, so mutation is occurring, not mutation, hypermutation, very rapid mutation is occurring in the receptors, and this is somatic, this is not genetic, this is acquired, this is we are making all the B cell receptors undergo hypermutation. So that, why? So that they learn how to respond best to the given antigen. Okay, square type antigen, make this receptor. Okay, round antigen, make this receptor. So we are teaching them every time to make the best receptor for the given antigen. Okay, so we are doing this so that these B cells develop what? Affinity maturation. So we are doing this so that all the B receptors develop affinity maturation. Do you understand the meaning of word affinity maturation? That means they learn to make an antibody which has the best affinity for the given antigen. So they are very specific. We want them to be very specific. So because of this, what is this term called? Affinity maturation. So can I say follicular dendritic cells help, okay, what help in doing two major things in the B lymphocytes. What are the two major things? That is, they help in doing somatic hypermutation and affinity maturation. Somatic hypermutation and affinity maturation in the germinal center of the lymph node. Are you clear with this? Now, this is a major thing. So B lymphocyte training and development is very much dependent upon follicular dendritic cells. Also, they need an enzyme. Okay, so we need an enzyme, so that sometimes teachers are very strict, you need a mediator who can say, koi baat nahi, ho jayega. So they need a helper here. So there is an enzyme which helps in this somatic hypermutation. Okay, so which is the enzyme which helps in this somatic hypermutation? This enzyme is called as, what is this enzyme called as? This enzyme is called as AID. Okay, so what is AID? Activation induced cytosine deaminase. Okay, activation induced cytosine deaminase, AID. So this enzyme helps in proper somatic hypermutation of the B lymphocytes. So what did you learn? You learned that all the antigen presenting cells will present the antigen to the T lymphocytes. All the antigen presenting cells will present antigen to the T lymphocyte, except follicular dendritic cells which go to the lymph node and they present antigen to the B lymphocyte. So all the antigen presenting cells will present antigen to the T lymphocyte, except follicular dendritic cells which will present antigen to the B lymphocytes. You also learned that FDCs are very important for the proper development of B lymphocytes, and they help in affinity maturation and somatic hypermutation with the help of an enzyme called AID, which is very helpful in this. Okay. Now, suppose if teacher is infected. Okay, suppose teacher gets infected. Who is the teacher? Follicular dendritic cells. It's infected. Okay, so teacher itself doesn't know anything. Teacher itself doesn't know anything. So can it teach the students? Obviously not, isn't it? So same thing here. If the follicular dendritic cells are infected, they will not help in proper training of the B lymphocytes. So this occurs in which condition? HIV. So HIV is very notorious. HIV is very notorious because HIV makes follicular dendritic cell as its reservoir. So what is the reservoir of HIV? Follicular dendritic cells. Since the follicular dendritic cells become reservoir of HIV, antibodies are produced in HIV. In fact, you get hypergammaglobulinemia, but all the antibodies are waste because they are not specific. They have not developed affinity maturation. Okay, they have not undergone somatic hypermutation. So antibodies are produced, but all antibodies are waste antibodies. Do you understand that? Okay, so that's about your antigen presenting cells. So what are the antigen presenting cells? 3 antigen presenting cells: B lymphocyte, dendritic cells and macrophages. In dendritic cells also we have 2 type of dendritic cells: follicular dendritic cells, and we have interdigitating dendritic cells. Perfect. Now let's come to the T cells. Okay, so you now you have studied about Kathappa, isn't it? So in our movie we have twin Kathappas, isn't it? So but when I talk about T cells, okay, so when I talk about T cells, okay, so now in the movie there were 2 kings, isn't it? So there were 2 brothers who were fighting for the throne, isn't it? Who was the 2 brothers? One was Bahubali and other was Bahubali's brother, no? So what was the name of that Bahubali's brother? What was his name? Ballal Dev, isn't it? Same, perfect. So these are 2 brothers here, okay? So we have here 2 brothers, okay? So we have 2 brothers here now. So one is called CD4 lymphocyte, the other is called CD8 lymphocyte, okay? So CD4 is the Bahubali and CD8 is the elder brother, not big number, so it is Ballal Dev, okay? So Ballal Dev. So now we have 2 brothers here, okay? So now these are 2 brothers fighting for the throne. So Bahubali says, I will become the king. CD8 says, no, I will become the king. So mother of Bahubali said, see, it is very simple. We'll do a competition. Whoever wins the competition will become the king. Okay. So this was a simple rule, they said. Now, that was the rule of the story. So the rule of the story was followed. Okay. Rule of the story was followed. So what happens? So first they said, we'll give antigen to the bigger brother. So all the antigen presenting cells were said to give antigen to first to CD8 cells. So as soon as the antigen presenting cells gave antigen to the CD8 cells, what happened? So they brought some antigens, they brought some bad antigen, okay, some bad pathogen they brought and gave it to CD8. So CD8 got very angry, he said, what kind of antigen you're bringing, such bad antigen you're bringing for me. So what did CD8 do? So CD8, as soon as the antigen presenting cell gave antigen to CD8, CD8 made small holes in the body of the antigen presenting cells. Okay, so it made small holes in the body of antigen presenting cells and it put bomb inside it and it bursted okay. So what was this? This cell died, okay. So what was this phenomena called as? So holes means perforin, okay. Bomb means granizyme. So granizyme is an enzyme which activates apoptosis. So perforin makes the holes in the body. Granizyme activates the apoptosis and this cell dies. So whichever antigen presenting cell gave bad information to CD8, CD8 only did one thing with them, he killed them. So it used to kill by perforin granizyme pathway, or sometimes it can even use fast ligand pathway to kill. But he killed everybody. Whoever brought bad information, he was killed. So then everybody said, what is this man? He is a very toxic cell. So they labeled him as cytotoxic T cell. Very toxic T cell. So he is a very toxic T cell. So this is a cytotoxic T cell. Very toxic T cell. So from that day, the antigen presenting cell says, no. We will never take an antigen to the CD8 cell. So from that day, no antigen presenting cell presents antigen to CD8 cells. From that day, no antigen presenting cell present antigen to the CD8 cells. So that's the rule that we developed. What is the rule? That self-antigen presenting cell, our own antigen presenting cells, have learnt over the time. They were killed and then they learnt. So it is a self phenomena. Our own antigen presenting cells do not present antigen to our own CD8 cells. So therefore, our own antigen presenting cells never present the antigen to our own CD8 cell. The phenomena of self. This is the phenomena of self, which you have to remember. Is everybody clear with this? Yes. So that is your self effect. Now let us see how did Bahubali did. So now same antigen presenting cells were told to present antigen to CD4 cells. So now same antigen presenting cells presented antigen to CD4 cells. Now when they presented antigen to CD4 cells, now CD4 cells immediately, they were very intelligent. Okay, so Bahubali was very intelligent. So he said, okay, tell me which is the antigen you've brought. He said intracellular antigen. He said, okay, so let me change into Th1 cell. So as soon as he said that this is an intracellular antigen, it changes into Th1 cells. These Th1 cells release interferon gamma. This interferon gamma changes the macrophage, okay, changes the macrophage with the round nucleus to the epithelioid cell. It changes the macrophage. It changes the macrophage. It changes the macrophage to epithelioid cells. It changes the macrophages to epithelioid cells. And these epithelioid cells will finally form the granuloma. Okay. So now you see who can activate macrophages? Th1 cells. They activate the macrophages via interferon gamma. So remember, because Th1 cells are doing this, okay, so these are T helper 1 cells which are doing this, so they form the granuloma. Now looking at the second phenomena was that they change into, so they said extracellular antigen is there. So whenever there is an extracellular antigen, they change into Th2. So Th2 releases interleukin 4, interleukin 5 and interleukin 13. Okay, so Th2 releases interleukin 4, interleukin 5 and interleukin 13. Now interleukin 5 everybody knows activate eosinophils. Interleukin 13 produces lot of mucin and interleukin 4 stimulates the B cells to produce immunoglobulin E. So remember, if you look at this, these are Th2 cells, they can form interleukin 4 which can stimulate the B cells to form immunoglobulin E. They can form interleukin 5 which can stimulate to form eosinophils and interleukin 13 which can activate the mucin. So now whenever the extrinsic antigen form, they can form eosinophils, they can activate the B cells and they can release a lot of mucins. Now here one point you should remember. Do you know hypersensitivity reaction? Do you know hypersensitivity reaction? So hypersensitivity reaction you study in microbiology in so much detail, isn't it? So what is hypersensitivity reaction? It is an exaggerated response to the simple antigen, okay, exaggerated response to a simple antigen, okay. Now suppose a very innocuous extracellular antigen comes, like let's say hay, simple hay, dust, pollen, okay, and then suppose there is super activation of Th2 cells. These Th2 cells release lot of interleukin 4, lot of interleukin 5, lot of interleukin 13, lot of mucin production occurs, eosinophils activate, B cells get activated, lot of immunoglobulin E production occurs. So this forms the basis of which hypersensitivity reaction? Type 1 hypersensitivity reaction. So whenever we talk about type 1 hypersensitivity reaction, this stem is overactivated, that is Th2 cells are overactivated to produce these cells. Whereas suppose if this arm gets superactivated, that is there is an small intrinsic antigen and lot of Th1 cells are activated. Lot of Th1 produces lot of interferon gamma, lot of macrophages activate to epithelioid cells, lots of granulomas occur. So this forms type 4 hypersensitivity. Type 4 hypersensitivity. So type 4 hypersensitivity activates which stem? Th1 cells. Also remember, if CD8 cells are superactivated, that is also type 4 hypersensitivity. So type 4 hypersensitivity means that there are two types of cells which are activated, one Th1 cells and second CD8 cells. So whenever you can somehow relate to the condition where these two are getting activated, it's type 4 hypersensitivity. Okay. Let's see one more antigen. Okay, so now CD4 is getting activated. So intrinsic antigen, extrinsic antigen. Now there are some more antigens which can sometime come. Okay, there are some more antigen which can sometime comes. So you just saw the T cell, CD4 T cell. Okay, if it was an intrinsic antigen, it changed into Th1. If it was an extrinsic antigen, it changes into Th2. Sometimes it feels that this process can be treated only by the neutrophils. So then it changes into Th17. Then it changes into Th17. Okay, so interferon gamma was the function of Th1. Okay, interleukin 4, 5 and 13 was the function of Th2, and interleukin 17 and interleukin 22 was produced by Th17, and this activates neutrophils. Now neutrophils go and attack, okay, whatever is needed. So excessive activation of Th17 will lead to excessive neutrophils activation. So do you know which disease this is activated? Inflammatory bowel disease. Okay, so especially ulcerative colitis. So when you will study ulcerative colitis, you will study that interleukin 22 polymorphisms are very common in that. So you see a lot of cryptapses. Okay, so interleukin 22. So this will activate more lymphocytes. More lymphocytes will collect in the crypts. Okay, so remember Th17 activations are for neutrophils. Th1 is for internal, Th2 is for external antigen. Now, sometimes CD4 cells think that there is no need for immune activation. So Th1 cells also have a power of releasing one more interleukin. This interleukin is called interleukin 2. So although Th1 cells, okay, release interferon gamma predominantly, which activate macrophages to epithelioid cells, but it can also release one more interleukin, that is interleukin 2. So interleukin 2, first work of interleukin 2 is to paracrinally stimulate Th1 cells. So they keep on stimulating Th1 cells themselves. The second function of interleukin 2 is that these go and activate a special subset of T cells. So these are CD4 cells only, but these CD4 cells are called as regulatory T cells. Okay, what are they called as? Regulatory T cells. These are called regulatory T cells. Now, what is the important event of what is the function of the regulatory T cells? See, regulatory T cells, if you look at the regulatory T cells, okay, so if you look at the regulatory T cells, these regulatory T cells have a special receptor on them. Okay, so this receptor is interleukin 2 receptor. It has interleukin 2 receptor. Okay, so therefore interleukin 2 can come and activate T regulatory cells. They can come and activate T regulatory cells. Now, once the T regulatory cells are activated, once it stimulates these T regulatory cells, then what is going to happen? These T regulatory cells have the power to suppress the immunity. So these have the power to suppress the immunity. Okay, so these are CD4 cells only which have the power to suppress immunity. So imagine CD4 cells themselves suppressing the immunity. CD4 cell themselves suppressing the immunity. This is by a very important subset of CD4 cell called regulatory T cells. Remember, okay, so remember these T cells were very prudent to identify because they said that this is a very powerful mechanism of peripheral immune tolerance. This is a very powerful mechanism of peripheral immune tolerance. Do you understand the meaning of peripheral immune tolerance? That means that it does not respond to every antigen just like that. So it knows how to tolerate. So this is a very powerful mechanism of peripheral immune tolerance. So T regulatory cells can tolerate the antigen, okay, and this is a very powerful mechanism of peripheral immune tolerance. If you look at these regulatory T cells, they can be identified by special markers. Now it becomes very important to identify these cells, okay, because they also found that cancer cells, they are very notorious. Cancer cells, when they enter into the body, they know that there is regulatory T cells which can suppress the immunity. So these cancer cells will go and stimulate the regulatory T cells. Because these cancer cells stimulate the regulatory T cells, so they suppress the immunity. So the immunity gets suppressed. So now cancer cells can invade and immune system cannot do anything. So therefore it becomes very prudent to identify what are the markers to identify regulatory T cells. Remember, regulatory T cells can be identified by two markers. The first marker here is FOXP3. Okay, so the first marker to be used here in identifying regulatory T cells is FOXP3. The second marker to be identified here is a marker which could pick up interleukin 2 receptor. This is CD25. So CD25 is the marker to identify interleukin 2 receptor. So what are the two markers which can help in identifying regulatory T cells? It is FOXP3 and CD25. These are the two markers which help in identifying regulatory T cells. And remember, regulatory T cells are very powerful mechanism of peripheral immune tolerance. So now do you know that? So CD4 cells, when the time rises, can activate which all subset of T cells? They can activate Th1, they can activate Th2, they can activate Th17 and they can activate regulatory T cells. And regulatory T cells are a very powerful mechanism of peripheral immune tolerance. Okay. So now, suppose, okay, so FOXP3 is synonymous with regulatory T cells. Okay. So suppose if somebody says that FOXP3 is deficient, that is, there is no regulatory T cells, there are no FOXP3 cells, okay, there is no FOXP3 cells, then what is going to happen? So if there are no FOXP3 cells, this will cause a disease, okay, so this will cause a disease called as IPEX. What is a disease called? IPEX. So this will cause a disease called IPEX, okay. Now, what is IPEX? This is immune dysregulation. Immune dysregulation, polyendocrinopathy, entropathy, and X-linked disease. So see, IPEX, immune dysregulation, polyendocrinopathy, enteropathy and X-linked disease. So how do you remember it? Remember that they are brothers, okay, X for X, okay, Fox has IPEX. So therefore, FOXP3, if it is deficient, it causes a disease called IPEX, that is immune dysregulation, polyendocrinopathy, enteropathy and it's an X-linked disease. Are we clear with this? So is everybody clear with this? So now everybody said, wow, Bahubali responded so well to the antigen. My God, this should be our king. Who should be our king? Bahubali should be our king. So from that day, who was declared as a king of immune system? CD4 T cells. So CD4 T cells were declared as king of immune system. So who is the king of immune system? CD4 cells. So now Bhalal Dev got very, very angry. Okay, Bhalal Dev got very, very angry. How on this earth can you do like that? How on this earth can you do like that? So how can you make, okay, CD4 the king when I am the elder brother? So he got very, very angry now that I should be made as a king. Why Bahubali as a king? So then mother of Bahubali said, see, he's an elder brother, so he should also be given some rights, isn't it? You can't just take all the power from him. So some power we have to give to him also. After all, he is also from a royal family, lymphocyte family. So they said, okay. So what was decided was that all the army, all the antigen presenting cells will come under the control of CD4. So they have to give antigen to CD4. Whereas all the self cells, okay, will have to present the antigen to CD8. So who are these self cells? Who are these self cells? Remember, on this earth, okay, on this mother earth, we have only three types of people. First is the kings, second is the army, and the third is the common people like you and me, okay. So army and king is CD4 and antigen presenting cell, they are gone, okay. So who are the self cell? People like you and me, okay. Common epithelial cells of the body, simple cells of the body, all the epithelial cells of the body. So whenever they have some problem, they have to go to CD8. So what did this cell says? No, we will not go to CD8. We will never go to CD8, okay. We will not go to CD8, okay. So then everybody said, why will you not go to CD8? No, he will kill us. So then they said, that's the purpose. Whenever you are infected by viruses or whenever you are infected by cancers, you go and take your problem to CD8. CD8 will do only one thing with you. They will make small holes on your body and he'll kill you by perforin granzyme pathway, or he'll kill you by fast ligand pathway, and that's all, you finished. Your apoptosis is done. So that's how. You remember when we were studying cell injury chapter, then I told you that all the cancer infected cells or all the virus infected cells prefer to do apoptosis. So how do they do apoptosis? So once they come to know that they are infected by viruses, or they come to know that they are infected by cancer cells, they will go and present this antigen to CD8. As soon as they present the antigen to CD8, CD8 will kill them. So that's how they undergo apoptosis. That's how they undergo apoptosis, by perforin granzyme pathway. So is everybody clear with us? Okay. So now what's the rule that you learned? The rule is that all the self cells are going to present antigen to the CD8 cells. All the antigen presenting cells are going to present antigen to the CD4 cell. That's how the presentation is going to work. And who is the king of immune system now? CD4 cells were declared kings of the immune system. Now there's another problem. What was the another problem? The another problem was that, what was the problem? Problem was that now they are royal family people. CD4 and CD8 are royal family people. So they won't just allow anybody to come into and present the antigen to them. What does that mean? That means, let me give you an example. Suppose a soldier has caught an antigen. So he will not barge into the room of the king and say, see, I've caught an antigen, do whatever you wish to do. Okay, he can't do that. Okay, or a self cell, a poor self cell. Okay, so cannot go into the direct room of the king and say, see, I'm infected by virus, do whatever you wish to do with me. You can't do like that, isn't it? So there has to be some rule. Okay, so there has to be some peon or some intermediate person who's going to take the message from this and this side. Okay, so therefore this intermediate person who helps in taking the messages from here to there, these are called as MHC complexes. Okay, so what are these complexes called as? MHC complexes. These are called as MHC complexes. So let's understand them. All the antigen presenting cells have a MHC molecule on them. Okay, so this molecule is called MHC2. All the self cells have one MHC on them. This MHC is called MHC1. So all the self cells have MHC1. All the antigen presenting cells have MHC2. Okay, so now these are the mediators, these are the peons who will give the information. So CD4 will take information only and only from MHC2. CD8 will take information only and only from MHC1. So he doesn't know self cell, he does not know antigen presenting cell. Okay, so can I say all the self cells have which MHC on them? They have MHC1 on them. And all the CD8 cells will take information only from MHC1. Okay, so this was the rule that was developed. All the antigen presenting cell, from wherever they will catch the antigen and come, they will give the antigen to MHC2. And once they give the antigen to MHC2, CD4 will be able to recognize them. So CD4 will recognize the antigen only if it is presenting through MHC2. So this was a very, very important event. Okay, so much so that suppose there is a deficiency of MHC2. Then CD4 does not know antigen presenting cell. Even though antigen presenting cell is standing with the antigen, CD4 would say, I will not take antigen from you, I don't know you. It will not take antigen from this person. So this disease was called as Bayer lymphocyte syndrome. What was this called as? Bayer lymphocyte syndromes. Okay, now this was called as Bayer lymphocyte syndrome. Okay, so Bayer lymphocyte syndrome, is a syndrome in which there is no MHC2. Because there is no MHC2, CD4 cells will not be able to identify antigen presenting cells, any antigen presenting by antigen presenting cells, and they will not be able to act. So this is called Bayer lymphocyte syndrome. So all these diseases which I am teaching you, all these are immunodeficiency diseases. I am teaching you side by side so that you remember it, because if I teach you together, you will not be able to recapitulate it. But if you study side by side, you will not forget it ever. Is everybody clear with this? Yes. So now once we are clear with this, okay, so now let us see how is the MHC molecule. In the next video, we are going to see how does MHC act. So let's see the MHC act.